Okay, yeah, well, thanks for inviting me. It's great. I came here in October. I was a professor in Canada at McMaster University for 12 years before coming here. I'm a chemical engineer by trade. If you want to go down further, it would be chemical process design would be and process systems engineering would be the subgenre. But I've really had my career around energy systems. So it's really the big picture from what I do is about really identifying the best technologies to choose for energy management and transitioning ourselves into a more sustainable world. So we do a lot of, in terms of the actual technologies, they can be anything with coal, gas, nuclear, shale, biofuels, wind, solar, like basically any resource, converting it to, I do a lot with fuels because I'm a chemical engineer, but electricity as well. And then everything in between, how it's transported and managed globally. A lot of what I do is very collaborative, working with a lot of different industrial or academic partners all around this campus and elsewhere, where someone has a new membrane, a new process, a new catalyst, a new reactor, a new technology. And we will sort of design a chemical plant using that, or a power plant using that technology. And then we will sort of evaluate it from an eco-techno-economic analysis point of view, which is to look at like the life cycle, the environmental impacts, and the economics together. And we basically have a big picture view. Should you do this or not? I would say 80 to 90%, I say do not do this, right? And that's the reality of research, right? You have to make 9 failures for that 10th one that is worth pursuing. And so we have a very technical skill set in my group, but it's a very big picture application. So that's what I'm going to talk about today primarily. So I was in Canada last 12 years. So this is a concept that I've been proposing called the Transatlantic Energy Bridge. And it's really addressing energy resiliency in the Western world. Specifically, in this case, how to get energy from Canada to Europe. So I came here in October, and one of the big reasons I transitioned is because Europe is a very exciting place to be in the world of energy. Like, I don't want to be on the continent right now. I'm quite happy here in Norway. But Norway is actually in a very good position. Canada could be in a good position if it got its act together. And Europe is very exciting for research because they're actually thinking about what's going on and actually trying to do stuff in a sort of a fire emergency scenario. So right now, for me, this is a really exciting place to be. So I'm just going to talk to you about some of these ideas. That's really the basis of me coming here and establishing these networks and getting to know everybody here. So this is my resiliency meter. Okay, so we want to be here. We want reliable, secure energy. We want to take it for granted. Like right now, the light's on, power's working, and we didn't think about it. And that's a good situation, right? And we want to keep it that way. And that's really what I mean by energy resiliency. Like the less you have to think about it, the better. I want to highlight a Canadian case study in resiliency. And this is my short version for non-Canadians. In Canada, the word pipeline is like a dirty word because it's so embedded in the political infrastructure over the past several decades. So your support for or against pipelines is a major, major political issue there that will just determine elections. It's to the point, actually, where 2 provinces, Alberta and Saskatchewan, are now officially proposing to leave Canada, something called Wexit. Quebec, in the French province in the east, had tried to leave in the 90s and had 49% of the vote. If they had made it to 50, they would have. So in Canada, the infrastructure is, the constitution is such that you can just leave it by vote. And this is an active threat because of the dichotomy between west and east and right and left and red and blue. And pipelines are a major, major part of that. So in Canada, Canada is one of the largest oil producers in the world. It's second in the world for conventional oil, for petroleum products, including shale oil. The oil sands in Western Canada. But it's a massive, massive amount of oil being produced here. And generally, we ship it to the United States. Okay, so this is a product in large part of international mega energy companies that they might own a Canadian subsidiary that drills it, but then all the refining happens in the Gulf region in the United States. And then the refined products actually make it back up into Canada. And Canada does not have a pipeline to connect west where it produces and the east where they have some refineries. They're incapable of refining enough for themselves, and so they're heavily dependent on the United States, or at least the United States-centric supply chain, to bring in energy. These blue lines so these black lines are existing oil pipelines. these blue lines are proposals at various levels that have happened over the past 12, 15 years to try to bring oil either through the nation to the eastern half, all the way out to the east and supply Europe, to try to go out to the west and supply Asia, or to go just increase the supply level south, because all the pipelines are full and actually ship it by rail right now, and that's not great. We've had some very catastrophic rail accidents with a lot of people dead from oil rail catastrophes. So these are all very heavily involved in the politics of the region. The only one that has actually started over the past 15 years is basically twinning an existing line, and that took about 15 years. And in this very, very comical government mishap, basically, 10 times over budget, and still hasn't been built yet, blah, 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 right? So one of the key things is, half of the energy supplied here from oil comes through this one pipeline called Line 5. The governor of this state called Michigan has made an election issue and won on shutting it down, and potentially has the power to shut down half the energy supply to Canada with one election, which they have no influence over. So Canada is in a very precarious situation in terms of energy resiliency. Now, the relationship with the United States is very strong historically, but as of late, especially with the Trump administration in particular, which has been pro-pipeline, but anti-Canada in many other regions, the trade balance has been really upset. And then Joe Biden, for example, on his very first day in office, within an hour, they elected to shut down the pipeline they had planned after 15 years of planning and 4 years of construction. So it's just like on somebody's whim. And Canada has basically no new infrastructure for 15 years. So they're in a very precarious situation. And we can see how resiliency is visible when you look at energy prices. So what I've done here is I've taken the major North American benchmarks in oil, in blue, gas in green, and coal is yellow. Everything is on an inflation adjusted value. So it's in August 2022 US dollars. And then it's per gigajoule. So you can understand on an energy content basis. All right. And this is since 1984, or as far as the good data goes. Coal, as you can see, is pretty much constant and cheaper on a per gigajoule basis. It's very smooth, very reliable. It had an all-time record jump from the Russian invasion. Okay. Oil and gas have been almost entirely coupled on an energy basis for almost 100 years. Okay, and they trend together. You can see individual blips and wars and things like that with one or the other, but they predominantly trended together. And remember, these are inflation adjusted. Okay, so this is not just real dollars, it includes inflation. So the sort of real cost is truly getting higher in this region. So we have Hurricane Katrina in the United States. This was a major impact in the Gulf region with infrastructure. It became very difficult to store and move oil, but not so much the gas. So oil became very expensive. We have impacts like the energy crisis and the recession, but this is when gas and oil started to decouple, but it was firmly in place in 2009, right after the recession, when hydrofracking became fully commercially mature and widely and very, very rapidly deployed across the Western United States. And that completely shifted the paradigm of energy. And you can see this. I mean, this has never happened between oil and gas in the previous 100 years. And, they have their own trends now. An oil crash not impacted gas. You see things like, here's the COVID pandemic. This is West Texas Intermediate, but the future actually went to -40 and it's never historical lows. You had to pay to get rid of it. We had the Texas freeze. So there was like 3 days of cold weather in Texas. It froze some of the pipes and it sent gas prices to all-time record jumps, and electricity as well. Then we have the invasion of Ukraine, which of course sent everything spiraling. So if you just step back and you have like left half, right half, you see like normalcy and insanity, right? And this is kind of like the canary in the coal mine, right? Now Canada hasn't built anything during this nonsense time. But what you end up seeing is like, okay, we cannot handle in the same way that we used to like world events. Okay, so, we're really kind of here. We have more uncertainty, we have higher prices, we're still functioning. Okay. I want to look at electricity. I'm going to move now with some European information. So on the left, we have Canada. On the right, we have EU. These are sort of energy mixes of the different grids as a whole. basic trends in both Canada and the EU, things are rising as we grow and produce more, but coal is decreasing. Okay, that is true across the developed world for the most part. Nuke is pretty much constant in Canada and decreasing in the United and EU after the Fukushima blast that dropped it. I can talk about that, but that was purely political. Gas is rising, renewables are rising. There's a couple things I want to point out. Is one, that despite the fact that the Western world has really been consistently shrinking their coal use, coal-related CO2 emissions are at all-time high because China and India are growing faster than we can decline. And at some point, you can get rid of all of our stuff, it won't even matter anymore. So all the work you do here is undone over there at that level. And we're also shipping, all our manufacturing is there, so we're still using coal. Anyway, so that's something to keep in mind. The other thing is renewables. So like in Europe, for example, 23% of our generation, but it's really up to 50% of capacity. And so that just tells you that has to do with resiliency because we can't consistently produce the capacity, right? So sometimes you can hit everything, sometimes we're zero, depending on wind and sun. So there's some issues there I'm not going to get into about operability that can be a major factor, but it gives you a kind of a picture of what's happening with the mix. But we still have the impacts from the big two elephants in the room, which was COVID and the Russian invasion. So prior to the invasion, at the point of the pandemic, we had in the EU 35% of its natural gas and 25% of its oil from Russia specifically. That's a huge chunk to put all your eggs in one basket, so to speak, right? So you're so heavily dependent, or were so heavily dependent on Russian oil in the EU, just like in Canada, they're half of their supply is coming from this one pipeline through Michigan. Okay, and in that case, it's still functioning, but they're teetering on the edge. Right? It's kind of a warning to them. Learn your lesson here. At the same time, we have global supply chain disruptions from the pandemic. It's impossible to ship things, get materials, demands down. So we had things were getting quite nasty when it happened. And then you are probably all familiar now with electricity prices. I have, in this case, I just have mainland numbers. The Norwegian numbers follow the same trends. In our part, they're not as high. But in general, you had relative normalcy. And this is pre-pandemic, so this is, I would say, was normal, last time we were normal. And we had relative normalcy. These are in euros per megawatt hour. Okay, and then we had the pandemic, and then we started having, the accused of Russia and then the actual invasion. And so we went up, we're really about 6 times the price from the invasion, and then we had later insanity 10 times, pre-pandemic prices in Europe. And this is kind of the reason why I was recruited here. Things are getting insane and okay, we need alternative energies and dealing with situations. So this is a lot of what I do. All right, and then we've kind of hit back down. This was kind of a shock to me living here over the winter and the heating bill, all electric. And we're coming back down again. But I mean, look at the left half, right half, right? Normalcy, insanity, and we're in insanity still. So, I mean, if we want to recap, we've had three record-setting events in just the last 2 years on the markets. We had the pandemics, we had absurd record negative prices of oil. Okay, you couldn't get rid of it. Texas freeze, record single month price jump, and that's for the whole month in gas, even though the freeze is only 3 days. Basically, the dailies went so high that the whole month average was still a record high. And then the Russian invasion, right, record high prices of coal. And this is all adjusted for inflation, right? This isn't just real dollars. So what does that say about the health of where we've been, right? It's guns, germs, and weather, right? And these are not new things. We've had those since the dawn of civilization. So if we can't handle guns, germs, and weather, do we think it's going to get any better? We're just waiting for things to calm down and somehow everything will be okay. We can't handle more of this. It's going to happen again someday. So this is really just kind of a big wake up. I mean, we're really more down here, right? World events are causing meaningful disruptions, and that's very, very true in mainland Europe. And it's not even just a first world problem. So I have many colleagues at different universities in South Africa that I collaborate with. And we have to schedule our meetings based around when the rolling blackouts are going to be. So okay, I have 4 hours electricity on this Tuesday morning. So we'll pick our meeting time on that, in that period, right? And they're down to less than a third of the day now. They have electricity available. And so it's insane. And so this is a good example. There's a lot of things wrong besides just energy prices, for example, and they had a lot of infrastructure problems. They have a real technical expertise problem. But then the global prices got so bad that they just couldn't afford to buy stuff anyway. Everything is just getting the same. So their country is deflating. Like their GDP is going down. They are just retracting. And they're at a point when they're worried about famine because they can't get irrigation pumps to run enough to irrigate the land. So like they're in a really serious situation. And so like it's already happening on the other parts of the world. They're in the red. Okay? Impact daily life, growing backouts, ongoing energy scarcity. We don't want to get here, but we really could be. Not that far off. So we have to be very concerned with energy resiliency, but it's very hard because infrastructure related. Infrastructure is very hard. After 15 years in Canada, they're building one pipeline after all of that, right? Like that's not going to do it. So this is a situation between Canada, Norway, Russia, and Europe, and the rest of Europe pre-invasion, okay, in terms of energy flows. So Europe is getting a large amount of gas and LNG from Norway, basically nothing conventional oil and biomass, but lots and lots of natural gas. This is why we have such a nice view, right? It's funding everything here, but even more from Russia, and then also lots of oil products as well. You can see relatively, I tried to scale the euros about the same. It's good to think of it in that way. A little bit of wood. Canada is just nothing, right? All of their infrastructure heads south to the United States, and there's a little bit that goes out west, but most of that just actually kind of goes like this, right back up there. I don't know. So it's actually still going to Texas, even if they get it out to the Pacific Ocean. So, Canada isn't really contributing. So much of what I've been trying to do is to try to build that bridge. So I want to get to something that looks a little bit more like this. Okay. When it comes to Canada, we can potentially provide a lot of non-conventional or non-oil products. Yeah.
Just on the previous slide, so you didn't put the gas and LNG exports from the US to Europe, or?
There's very little.
Okay.
Now, I don't have US numbers. I know this is a Canada focus on, so I don't have US numbers on there. Yeah.
But if you put US, I guess it would be quite a significant.
There would be more.
Yeah.
Yes. And because, the US has switched from an energy importer to energy exporter over the last 10 years because of the hydrofracking.
Yeah.
But it's true. It does go to Europe. And so one of the things, though, is that Canada, its gas products would actually go through the United States in some of those cases. At least the oil products would. So that's why I have nothing here for the oil, really, because it's really going to come that direction. And so that's a major question for Canada. You just send it to America and let them deal with it. Or can we build our own supply chain? My vision is Canada can take care of it. It puts big boy pants on and build some infrastructure. So basically, we need to have a world where how do we manage Europe, where these are shrinking to potentially zero from Russia, and they're 90% to 100% down. And how do we supply them? Where does this difference come from? Like other than the fact that they'll need to have demand reduction, efficiency improvements, but Norway probably can't increase gas and LNG more because it's maxed out for the most part in terms of production rates, right? Like you can just keep going, crank it out and sell it at a high price and make it bang, which is what's happening. But what can we do? And actually, I've been working with Equinor since 2017 on the green one. So how do we get more stuff here that isn't just gas out of the ground? And then within Canada, they can also be a little bit clever. So I'll talk about these issues, and they're actually quite linked because Norway and Canada both sit in a similar resource provider situation, but they have their own limitations at the same time. So they have to be a little bit clever about what we can do. So this is the crux of the transatlantic energy bridge. So I want to get from one side to the other, and to do that, we need pieces of this bridge. Like, what are the different technologies and the different ways that we can get energy in the mainland Europe, okay, given all the restrictions that we have now. So this is like the next 10 years of my program, right? Looking at these things, building on the previous. So the first one I talk about, and this one's very interesting because this one's very relevant for Canada. But here at NTNU, they just launched a nuclear energy team. Okay, so sort of looking into recognizing that the world's like, okay, we really do need nuclear now. Again, so the politics are kind of coming back up, but it's still in many places, it cannot do research. You're not allowed to do research in nuclear energy in many parts of Europe, right? We don't have any nuclear reactors in Norway anymore, right? So, but like you could. So there's a recognition here, but Canada is in a much better position in this particular one. But when it comes to nuclear energy, it's not really about electricity. Canada has 80% of the world's uranium in just one mine in the province of Saskatchewan. So that one mine produces 80% of the world's supply. And it's got a 300, 400 year supply just in that one mine at the current rate. So there's a lot there. And, we think about nuclear energy, we think about electricity. And if you don't know a lot about it, this is the electrical department mostly, so you would understand a steam cycle probably. And it's basically like you just have a reactor that gets hot and there's different coolants which take the heat away and that goes into some kind of steam cycle. It's some of them. It could be a deuterium steam. There's more advanced technologies. But at the end of the day, taking heat. So you don't have to make electricity. And this is very limiting because usually you want your nuclear power plant nearby your urban area that's going to consume it because of the losses of transmission. It can be quite significant, especially in Canada, which is very, very big. So there's another way is you can use that heat to store it in a chemical form. And you do that by basically taking, all of you aren't chemical engineers, but you can take molecules which have low energy and you sort of fuse them together into molecules that have high energy stored in those bonds. So our word is endothermic, which means you absorb heat and store that energy into a bond. So a great example is you can take hydrogen and carbon monoxide and lay them over catalysts, and these different catalysts you can make alkanes, something like octane, decane, dodecane. So basically synthetic diesel, synthetic natural gas. And the energy of that uranium gets stored now in a synthetic diesel or gasoline that you can blend into an infrastructure. Okay, and this is actually Nazi technology in terms of the catalyst part. So that was captured in World War II, and that was what they used to provide themselves with diesel for their pans or tanks. And we captured that and employed that within our industries. You can make alcohol, so methanol, ethanol, butanol, all sorts of different high energy alcohols. You can make jet and kerosene, so aviation fuels from these. Dimethyl ether, as well as another, it's like a propane. It's like more environmentally propane, I would call it. But you can do all sorts of things once you recognize you can take the heat and store it into a bond, because there's just a huge number of possibilities at that point. And you can source the carbon from a fossil fuel. Natural gas is really good, but you can use biomass as well. So you have like a biogenic carbon source. And so you can get hydrogen from water or from natural gas. And so, in our group, we'll look at for 10 years of all these different combinations and ways of taking nuclear energy and storing it into a fuel. Okay, and all the different ways of doing that. There's a lot of options. And so one of the main reasons why this fits in the bridge is that Eastern Canada is one of the world's leading places for nuclear power. It's been, running for 60 years. The world's first research reactor is at my university, McMaster, and it's on the east. So they have the regulation, the infrastructure, and the expertise to make it happen. So they could produce these. These can be in locations away from a city, for example, and then built into the existing infrastructure if we could get things east. We can at least make the chemicals. Okay, so the next thing I want to talk about is hydrogen and hydrogen carrying chemicals. So this is very sexy right now. There's some questions about wisdom when it comes to hydrogen, but this is an absolute possibility on the energy bridge. And I'll talk about that in a minute. My job, so this aside, so when I interviewed for this position, somebody asked me what I thought about hydrogen energy, and I was like, well, should Norway switch from electric cars to hydrogen energy? And I just said no, and everyone, because it was like, how could you say such a thing in your job interview? Obviously you have to say hydrogen. I didn't, but they still hired me, so maybe that's okay to say those things. But so when we talk about hydrogen energy, there's different colors. There's no uniform color guide, but this is a common one we use in Canada. So gray is the most common in the world. It's like 98% of hydrogen production. You just take natural gas, you react with steam, and the H comes off of the methane, but it's in a very high energy form, and the methane started with high energy, so the energy comes from the methane with the natural gas into hydrogen. So, but it's all the carbon, though, comes out of CO2. And so it's kind of, it's carbon intensive. It's actually quite carbon intensive. Hydrogen gas per kilogram has a higher CO2 impact than gasoline or diesel, for example. Blue means you capture and sequester. Green are things like wind, solar, potentially nuke. So these are things you can do, but here's the major problem. When it comes to a hydrogen economy, there's a difference between hydrogen the molecule and hydrogen the fuel product. So we forget this all the time, but you can make hydrogen in chemistry class, but just by electrolyzing some water, but it's like small parts per million or small, mole fraction. in atmospheric pressure in this big mix of air. And that's not useful. We can't ship that. That's not useful. Just even hydrogen, pure hydrogen is only 0.011 megajoules per liter in density. Go down to the bottom right, gasoline is 32. So we want to ship that around the world. That makes sense to fit on a boat, but I can't do something 4 orders of magnitude smaller, right, to have any value and impact. So you have to think about compress the hydrogen, convert it to a liquid, or in this case, the better options are convert it to a different chemical and ship that chemical. I can convert it to methane, but that doesn't make any sense if I'm going to make it from the methane, so I should just ship the natural gas around, right? So you have really sort of existential crisis pictures. But the reason why this can make a lot of sense politically is because we can't build a pipeline in Canada to save our lives. We also, in Canada, we have 17 liquid natural gas terminals that have been permitted and 0 have been built. We have 0 in Canada, despite 17 approved permits, because we can get 0 pipelines into those terminals. So we have no LNG infrastructure. But LH2, greenlit from the government the whole way. So even though it's a tenth or not a tenth, a sixth of the density that we really want, we can do it because it's politically possible. So that's why it's on the hydrogen bridge or the energy bridge, right? So does that make a lot of sense? Another area is in wood and agri products. I'm going to just mention really quick, 85% of Canada's wood pellets are already going to the EU, and they're kind of maxed out. I mean, you can clear cut forests, but we can't increase that. That's already done, right? In fact, they paid us to burn it there. It's probably better if they just paid us to burn it in Canada because the shipping sucks so bad, but they have to burn wood for their bio initiatives, and it's probably better with all the diesel transmission of getting it there to just do it in Canada. It's a different story. But we can't get the energy in either way. So a better way are in crop products, which are, so Canada could double its beet production. I know you all love beet, the vegetable. It's so unpopular that they can double their production within 1 year because they have all the space and expertise and no one wants to eat it. But within 1 year, they can double it. There's a Canadian company that can make something called formic acid, which is a hydrogen and CO2 together in one molecule that's liquid at room temperature and pressure. So you can ship that in very safely and with some reasonable density. And there's a German company who would receive it, and they have a catalyst that breaks it back down into hydrogen and CO2, and so you can get your hydrogen out in Germany. So you make formic acid from beets, and you get hydrogen at the source, at the point of use. So that's a possibility. There's some things you can do with that. That won't solve everything on the bridge. Another big one is in waste to energy, and I've been doing this with Equinor for quite a bit, actually. We've been working with Petcoke and rubber. And so basically, if you gasify it, so if you don't know what gasification is, you just blow it apart at really high temperature and pressure. All of the atoms just fly around, they recombine into carbon monoxide and hydrogen. And then once you do that, you can put that over a catalyst to make whatever kind of fuel you want, just like you could in the nuclear case. And so you can blow apart your trash, you can blow apart rubber, like your garbage rubber, in this case, a lot of biomass, and our Petcoke is what we are concerned of in Canada. We have a lot of it. And we do, it starts to make sense once you have carbon taxes that are in a couple of years in Canada. I have a colleague, I think she's on the call, Corinna, but she works on the plastic part. And I think that's really important because it's a great way of getting rid of plastic waste, which we're not really doing what we should be with. Most of it gets incinerated, but we can actually make fuels from all of our trash and ship that across. So that's going to be another key part of the bridge. And then short term, we probably have to ship fossils. Now, people have been coming to German, and the Chancellor and the Japanese Prime Minister visited Canada over the past couple months. They've been begging for additional fossil fuels. The government said no. Okay, so there's no political appetite to ship additional fuels, especially LNG. Until that changes, we have to think about other ways in terms of getting the energy. But my approach is a little bit more sustainable. So I went kind of a whirlwind tour of where we're headed, like where I want to take us, and just more fossils isn't going to happen from Canada. Okay, so and from Norway it can't either because we're already maxed out for the most part. You can drill more, but you're robbing the supply that I think you want to have some longevity to. So instead, we're much more interested in all the other things we could do. If it's hydrogen, if it's anything derived from plastic. We've been working on rubber to synthetic natural gas. So can they make, which we can have a process that you can turn the rubber into a synthetic natural gas and that just goes right in the pipeline. right? Hydrogen's a big one because there are many proposals to build a hydrogen infrastructure outside Denmark and Germany. And then Norway has these offshore platforms, which would make hydrogen and feed into this sort of like North Sea hydrogen offshore pipeline into Europe. And there's a lot of opportunity for that actually as well for Norway. So the same kinds of technologies and ideas for both, but the situations are a lot different. So the answers are not going to be the same. That's what's best. And that's what I'm here to find out for the next 10 years. Okay, thank you very much.
Thanks, Thomas.